Hello students, welcome back again. In this video we are discussing an example based on simultaneous linear congruences. Okay, before discussing the simultaneous linear congruences, first let us know what is Chinese remainder theorem. What is Chinese remainder theorem? Okay, so it is very easy, students. Okay, look at how it is. Let m1, m2, m3, so on mr be positive integers, and these are relatively prime in pairs. Relatively prime means the GCD of two numbers, that is a and b, is 1. If the GCD of two numbers is 1, we say that they are relatively prime. Here the pair means m1, m2, m2, m3, m3, m4, m4, m5. They are relatively prime number. Okay, and b1, b2, b3, so are the arbitrary integers, means they are the numbers, and there is no restriction for this arbitrary. Then the system of linear congruences: x equal to b1 mod m1, x equal to b2 mod m2, x is congruent to so on. This is br mod mr as exactly one solution modulo the product. One solution modulo the product. The product is capital M is the multiple of m1, m2, m3, so on. Now, what is the working procedure? Working procedure is very simple. We have 5 steps to follow here. The given we have system of linear congruences. These are the system of linear congruences. X is congruent to b1 mod m1, x is congruent to b2 mod m2, and so on. X is congruent to br mod mr. The step number 1, we are verifying whether the pair of m values by taking m1, m2, m2, m3, m3, m4, they are relatively prime or not. We are going to check here first for different value of I and j. Next, we are finding the product capital M. Capital M is equal to product of small m1 into m2 into m3, so on mk, or you can also write this is mr, and r takes the value, or it's already final value, you can write it. Similarly, find capital mk. Capital mk value is capital M, that is product of numbers, divided by mk. Mk means mi's. K takes the value 1. For example, here capital, take small k is equal to 1, means here you will get m1 is equal to capital M divided by small m1. This is. Similarly, we can find out capital M2, capital M3, and so on. Next, consider a linear congruence, that is mk. Capital mk x is congruent to mod, this is small mk, are satisfied with the unique value of this xk. Finally, the unique solution of the system of linear congruence is given by x is congruent to b1 into capital M1 into x1 plus b2 into capital M2 into x2 plus so on br into capital R into br into capital mr into xr mod. This is product. M is a product. So let us discuss one example based on this. Okay. Solve the system of linear congruence. X is congruent to 2 mod 3, and x is congruent to 3 mod 5, and x is congruent to 2 mod 7. First, you can compare these equation with the standard one, that is x is congruent to b1 mod m1 x is congruent to B2 mod M2 and x is congruent to B3 mod M3. Then you can able to write, by comparison you can able to write what is the value of B1. B1 is 2, B2 is 3 and B3 is 2. Similarly, M1 value is 3, M2 value is 5 and M3 value is 7. Okay, M2 5, M3 7. Next, let us go step by step. What is step 1? Okay, step 1, what we are doing? We are going to calculate, we are going to verify the relatively prime of the pairs MIs. First take 3 and 5 and verify whether they are relatively prime or not. Next take 5 and 7. Next take 7 and 3. Okay, so all are relatively prime numbers. How to verify this? So just you can divide 5 by 3. 3 ones are 3, the remainder is 2. Again this 3 divided by 2. 2 ones are 2, the remainder is 1. Next 1 2s are 2, the remainder is 0. So therefore, what is the last non-zero remainder? Non-zero remainder is 1. So you will get GCD 1. Similarly, you can verify for other 2 also. Okay, fine. Now, okay, step number 1 is over. That is, we have verified they are relatively prime number. Let us go for step number 2. Step number 2 is to calculate capital M. Capital M is product of M1 into M2 into M3. Okay, so you can multiply M1 into M2 into M3. 3 into 5 into 7. So 3 5 is a 15, 15 7 is a 105. Calculate step number 3. Step number 3 is you can find MK. Capital MK value is capital M divided by small mk, and k takes the value 1, 2, 3. Okay, you can write carefully. This is capital M1. Take k is equal to 1. Capital M is 1 is equal to capital M divided by small m1. And substitute k is equal to 2 here. M2 is equal to capital M2 divided by small m2. M3 is equal to capital M divided by small m3. So you can calculate. So just capital M value is 105 divided by small m1 is 3. Similarly here 105 divided by 5, 105 divided by 7. So what is the value of capital M1, capital M2, capital M3R, which is just, this is 35. Here you will get 21. Okay, 5 2s are 5 1s are. Again here you will get 15. 15 7s are 105. So therefore capital M1 is 35, capital M2 is 21 and capital M3 is 15. So after 3 steps, what is the 4th step is we need to consider a linear congruence. What is the linear congruence we need to consider? We can write, consider a linear congruence of the form mk x is congruent to 1 mod small mk. Okay, Fine. Now you can write three congruences by substitution of k is equal to 1, 2, 3. Take k is equal to 1, you will get capital M1 x congruent to 1 mod small m1, comma capital M2 x is congruent to 1 mod m2, and capital M3 x is equal to 1 mod m3. Just I substituted k is equal to 1, 2 and 3. You can write k takes the value 1, 2, 3. Capital M1 is, we know already, which is 35 x congruent to 1 mod small m1. Small m1 value is 3. Second one m2 is 21 x congruent to 1 mod 5, and 15x congruent to 1 mod 7 m3 value. Okay, now we need to find out the value of x in these three congruences. As we know the definition of congruence, if ax is congruent to b mod m, then this value 3 divides 35x minus 1. Here 5 divides 21x minus 1. Here 7 divides 15x minus 1. I will explain here, just concentrate. What is the definition of congruence? If A is congruent to B mod M, which implies that this M divides this A minus B. For example, if I write 5 is congruent to 2 mod 3, means definitely this 3 divides 5 minus 2. 3 divides 5 minus 2. 5 minus 2 is 3. Definitely 3 divides 3. So you have to remember in this form. So now tell me what is the value of x here. For what value of x? This total value is divided by 3, or 3 divides this total value. By taking x is equal to 1, 35 into 1, 35 minus 1 is 34. 3 never divide 34. So let us take x equal to 2. 35 to the 70, 70 minus 1 is 69. Definitely 3 divides 69. Therefore x value is 2 here. This is by inspection method. Next, here x takes the value. By taking x equal to 1, 21 minus 1 is 20. Definitely 5 divides 20. Similarly, by taking x equal to 1, 15 into 1 is 15 minus 1 is 14. 7 divides 14. So therefore x value is 1 here, and you call it as this is x1, x2, this is x3. Fine. Now finally step number 5 is general solution, or the unique solution we are going to write. What is the unique solution? Unique solution of given system of linear congruences is given by x is congruent to, we have b1 into capital M1 into x1 plus B2 into capital M2 into X2 plus B3 into capital M3 into X3 mod capital M. Okay, fine. Now X is congruent to B1. B1 value you know already. B1 value is 2. Capital M1 value is 35. X1 value is it is 2. Just you can go and observe above values, you will come to know this. B2 value is 3. M2 value is 21. X2 value is 1. B3 value is 2. Capital M3 value is 15. And this X3 value is 1. Okay. This is mod capital M. Capital M value is 105. Capital M means small m1 into m2 into m3. Small m1 into m2 into m3 value is, that is 3 into 5 into 7. 3 into 5 into 7 is 105. Okay, now you can calculate total value. You will get 233. X is congruent to 233 mod 105. Okay. So look at this is the remainder place, student. Since this is a remainder place, the remainder is greater than the divisor. Therefore, you can divide 233 divided by 105. 105 into 2 is 210. You will get 23. Therefore, in place of 233, you can write 23 mod 105. So, this is the solution of a linear congruence. Thank you so much for watching, student. We'll meet in the next video. If you like our videos, please subscribe it and share it. Thank you so much.